By now, you have built a solid mental model of how the ISM protects systems that organizations directly own and operate. You understand identity, endpoints, servers, networks, governance, and risk. This lecture challenges a common misconception you may already have encountered. The idea that moving to the cloud somehow changes the ISM, weakens its requirements, or shifts responsibility away from government. The reality is very different. The ISM fully applies to cloud environments. What changes is how responsibility is divided, not whether responsibility exists. When you move workloads to cloud platforms such as Azure, AWS, or SaaS services, you are not outsourcing security. You are sharing responsibility for security outcomes. The ISM is designed to work in exactly this kind of environment, where control is distributed, but accountability remains firmly with the organization using the service. The most important concept you need to understand is the shared responsibility model. In simple terms, cloud providers are responsible for securing the cloud, and you are responsible for securing what you put in the cloud. This distinction is foundational, and misunderstanding it is one of the most common causes of cloud security failures. Cloud providers take responsibility for the physical data centers, the underlying infrastructure, and much of the platform reliability. They invest heavily in physical security, resilience, and baseline protections. However, the ISM does not consider this sufficient on its own. From an ISM perspective, government responsibility begins wherever government data, identities, and decisions exist. This means that even in the cloud, you remain responsible for identity and access, management, data protection, configuration, monitoring, incident response, and risk acceptance. The ISM does not care whether a server is physical or virtual. It cares about outcomes. When you use infrastructure as a service platforms like Azure or AWS, the ISM expects you to apply the same principles you learned earlier. Identities must be controlled. Privileges must be limited. Networks must be segmented. Systems must be monitored. Vulnerabilities must be managed. The difference is that many controls are implemented through configuration rather than hardware. Cloud environments amplify both good and bad security practices. When you design securely, you can apply controls consistently and at scale. When you design poorly, misconfigurations can expose systems instantly. The ISM's emphasis on secure by design and risk-based thinking becomes even more important in cloud environments. Software as a service introduces another layer of abstraction. In SaaS platforms, you do not manage servers or networks directly. However, the ISM still applies. Your responsibilities shift toward identity governance, data handling, access controls, configuration of security features, and monitoring of usage and activity. A common mistake is assuming that SaaS providers are responsible for protecting government data by default. Under the ISM, that assumption is not acceptable. You must understand what controls the provider offers, how they align with ISM expectations, and what residual risks remain. Those risks must be assessed, treated, or accepted deliberately. Cloud security under the ISM is therefore heavily dependent on governance and documentation. You must clearly document where responsibilities sit, how risks are managed, and which controls are provided by the cloud service versus implemented by your organization. Ambiguity is risk. Another critical concept is visibility. Cloud environments do not automatically provide the same visibility as traditional environments unless you configure them to do so. The ISM expects you to maintain logging, monitoring, and incident detection capabilities even when systems are hosted by third parties. This includes collecting logs from cloud services, monitoring identity activity, and integrating cloud events into central security monitoring platforms. Without this visibility, you cannot meet detection and response expectations under the ISM. Cloud environments also change how you think about network security. Traditional perimeter-based models do not translate directly. Instead, segmentation, identity-aware access, and service-level controls become more important. The ISM does not mandate a specific architecture, but it expects you to design cloud environments that limit lateral movement and reduce exposure. Another area where cloud security intersects strongly with the ISM is data protection. Data may be stored, processed, and replicated across regions and services. The ISM expects you to understand where data resides, how it is protected, and who can access it. Encryption, access control, and data classification remain your responsibility. You must also consider supply chain risk. Cloud providers and SaaS vendors are part of your cyber supply chain. The ISM expects you to assess the trustworthiness of suppliers, understand contractual obligations, and ensure that security responsibilities are clearly defined. Trust is not assumed, it is assessed. One of the strengths of cloud platforms is their ability to support automation and consistency. When used correctly, this aligns strongly with ISM expectations. Automated deployment, configuration management, and policy enforcement reduce human error and improve assurance. The ISM encourages these outcomes, even though it does not prescribe specific tools. Risk management in the cloud follows the same principles you learned earlier. Not all risks can be eliminated. Some risks are accepted because cloud services enable critical capabilities that outweigh residual risk. The ISM allows this, but only when decisions are documented, approved, and reviewed. A key mindset shift you must make is this. Cloud security is not weaker than on-premises security. It is different. When designed well, cloud environments can meet or exceed ISM expectations. When designed poorly, they can fail faster and more visibly. Responsibility does not disappear. It becomes more explicit. The ISM deliberately avoids cloud-specific exemptions because it assumes that government must be able to operate securely regardless of technology model. This is why the ISM remains principle-driven rather than technology-bound. It is future-proof by design. The most important takeaway from this lecture is simple. Using cloud services does not reduce your ISM obligations. It clarifies them. You must understand where provider responsibility ends, where your responsibility begins, and how risk is managed across that boundary. When you approach cloud security with this mindset, the ISM becomes an enabler rather than a blocker. It provides the structure needed to adopt modern platforms confidently while protecting government data, services, and citizens.